Welcome back from that short break. We are still doing more examples on partial fractions on the case where the denominator has got what we call repeated roots. So we are moving on to the next example, that is example 5. Express 1 all over x plus 2 into x minus 1 squared in partial fractions. So I want to express that number into the partial fraction. So what we're going to do, we are going to apply the usage of how the repeated fractions or repeated numbers are treated. So I've got 1 all over x plus 2 into x minus 1 squared is the same as a out of x plus 2 plus b out of x minus 1 plus c out of x minus 1 squared. So what we're going to do is this. We are going to get the LCM, then after we try to substitute it. This is one is the same as a into x minus 1 squared plus b into x plus 2 into x minus 1 plus c into x plus 2. Then we go ahead and we do the needful. So you can say using the we use the monomial formulas, or we using the covering method. You can say using the covering method, using the covering up method, using the covering up method. You can start by saying if x equals 1, we are getting 1 equals a 1 minus 1, it affects, we get 0 plus 1 minus 1 still b is affected plus c into 0 plus a 2, you get a 2. So we are remaining with 1 equals 2c. So c alone equals a half. After getting c equals a half, we still also go ahead and we substitute in. And say if x equals -2, we go 1 equals a into -2 minus 1, we are getting -3, the whole of it squared, plus b is being affected, and again c is also affected. So 1 equals 9a. So the whole a equals 1 out of 9. So our a is 1 out of 9. Then after there, we are free to substitute in any number so that we can get the remaining unknown. I can still say if x equals 0. Now I'm using x equals 0. We're getting 1 equals a into 0 minus 1, we are getting -1. -1 squared remains as, can even verse it, -1 squared plus b into 0 plus a 2, you are getting a 2 into 0 minus 1 to -1 plus a c into 0 plus 2, we are getting a 2. So go ahead. This is 1 equals -1 squared, we are getting 1. 1 times a, which remains as a, then minus 2b, then plus 2c. Do we know our value of a and c? Then we are free to substitute them. We say 1 equals 1 over 9 minus 2b plus 2 into a half. So we are getting 1 equals 1 over 9 minus 2b plus 1. So rearranging it 1 and 1, when you collect them like terms, 1 automatically disappears. So we are remaining with 0 equals 1 over 9 minus 2b. So making it be the subject, we are bringing it here, we are getting 2b equals 1 over 9. So can we divide both sides by 2? So b alone becomes 1 out of 18. So after coming out with b, then we are free to substitute in that. We say therefore 1 all over x plus 1, x plus 2 into x minus 1 squared is the same as, do we know the value of a? A is 1 over 9. We get 1 out of 9 into x plus 2. Do we know the value of b? B is already 1 over 18. We say plus 1 out of 18 into x minus 1. Do we know the value of c? The value of c is already a half. We say 1 out of 2 into x minus 1, the whole of it squared. So this is the way how we can express that given in number into the required partial fraction.